Greetings, everyone. My name is VanderGoot. I am videoing in from Silver Spring, Maryland, where I teach in the architecture program at the University of Maryland. Great to meet you. The title of my talk today is Soft City, the Case of Harvard Forest as a Model for Suburban Development in the Temperate Biome. And in this talk, I'm really using Harvard Forest as a foil to get at a larger discussion of the term soft or soft city. So I'll talk about this term soft, a little bit about its history in the design disciplines, and I'll also introduce other projects alongside Harvard Forest in order to fully develop the ideas here. My research on Harvard Forest comes from the work that I did for my recent book, Architecture in the Forest Aesthetic. Harvard Forest was one of the 21 case studies in the book. The projects in the book were from all over the world, and they ranged in scale from the size of the garden, for example, Afterburn Garden in Canada, to the scale of the building, Murray Grove, which is a mid-rise building in London, UK, built out of cross-laminated timber, to landscapes like Future Library in Norway and Harvard Forest in Massachusetts, USA, and finally, to the scale of a territory and the city, like Canberra, Australia. So I felt like it was important to give you that brief background to the research that I did for Harvard Forest, because all of the case studies in the book fall within a particular geographic biome called the Temperate Forest Biome. And you can see that highlighted in the slide in the medium gray and in the black. And the title of my talk today, Soft City, the Case of Harvard Forest as a Model for Suburban Development in the Temperate Forest Biome, is because many of the ideas that I'll suggest today apply specifically to this climate zone. I'm using the term soft or soft city, which has already been used frequently in the design disciplines and in particular in architecture, alongside Harvard Forest, because when Harvard Forest is understood through that lens of soft, it becomes a design project or a model for a new kind of epigenetic suburb. And I'll unpack that term epigenetic a little bit more later, but an epigenetic suburb is an area outside of the most densely populated areas that has a form that's been generated by pre-existing site DNA, but has also had a soft shift or has morphed into something new because of influences that are outside of the pre-existing site DNA. The volume Bracket Goes Soft, which was published in 2012 and edited by Niraj Bhatia and Lola Shepard, discusses the term soft in the context of the design disciplines, and it also makes a call to further deepen and expand the meaning of that term in the context of design. One of the projects that's discussed in quite a few of the articles in the Bracket Goes Soft volume is the Kushicle by Archigram from the 1960s. It's described as literally soft because it's a malleable volume, but also one that can kind of go anywhere at any time because it's inflatable. Projects at a larger scale are also discussed as soft. And in this context, soft really describes the function or the performance of a system. So for example, software is discussed in cybernetics as something that is soft because its signals are hidden or invisible and they can go anywhere at any time. On the right-hand side of this slide is one of the case studies from my book, The Instant City, also by Archigram from the 1960s. And here you can see the instant city is a soft or flexible kit of parts that can create a city suddenly where there was not a city, and that city can be disassembled just as quickly. And of course, one of the main features of the instant city is its electronics or the use of digital devices. Lola Shepard, in her essay Site to Territory, offers 3 examples of soft territories, and one is the epigenetic territory. She discusses the NL Stott project by MVRDV in the Netherlands as an example of an epigenetic territory or design for an epigenetic territory. So the project is called the glass or the greenhouse zone. And what it does is it looks at the existing greenhouse zone, which is a patch, and it deconstructs that patch into its basic elements or its basic DNA, which is the greenhouse. And then it reconfigures the greenhouse so that it becomes a linear ribbon-like element along an existing road and canalway. The greenhouse also shows up in the middle of town centers across the territory. And in that context, it starts to take on the architectural language of those town centers. In that way, it morphs a bit from the original DNA of the greenhouse. So the greenhouse creates a new kind of territory, and it functions at the scale of the territory because it's a flexible medium that can spread out over space, but it's also a flexible medium that can respond to its context. And so it's that last point about a territory as soft when it is epigenetic that I most wanted to connect to the Harvard Forest Project. In my book, I described Harvard Forest as a kind of urbanism that has three primary layers: signals, stones, and trees. This slide here shows those layers in plan view and shows a particular area of Harvard Forest called Prospect Hill. On the far left is the Harvard Forest Field Wireless Network, which is a series of towers and armatures that send data across the globe. In the middle, you see stone walls that were built in the 1700s when Harvard forest land had been cleared for agriculture. And on the far right, you see the mosaic pattern of trees. And in particular, this image shows damage from the hurricane that hit Harvard Forest in 1938. And this drawing is a testament to the resilience and change of the pattern of trees in the forest over time. So the image you see here is of the Hemlock walk-up tower. It's one of the many structures that are peppered throughout Harvard Forest. It is an armature made out of simple like construction scaffolding, steel pipes. Typically, these structures involve some kind of stair so that people can get up to the level of the tree canopy. They also hold fairly sophisticated electronic equipment. For example, phenocams, which are mounted at different heights throughout the forest, take a continuous series of photographs that record things like tree leaf out in the spring, or that time in the season when leaves start to change and fall off the trees. There's also equipment that records changes in chemical composition in the atmosphere. This image is from a data archive that records atmospheric composition. This particular chart suggests a recent decline in the magnitude of carbon dioxide uptake in hemlock trees in the forest. That corresponds to the arrival of the hemlock woolly adelgid pest. And so it's interesting to see these changes, whether it's the result of something like climate change or the arrival of a pest. The great thing is that Harvard Forest has been recording these types of things in detail for 20 years now. And so what I would argue about this layer of urbanism is that it's soft and that it functions at the territorial scale. For example, the wireless network at Harvard Forest, which you see featured in the slide in plan view on the left, is soft in the sense that it's invisible, its signals are hidden, and it materializes as a rich data archive. But that data archive might be across the globe. And the tower armatures that hold that network, the visible pieces of architecture in the forest that are connected and part of that network, I would argue, are also soft because they're epigenetic. The tower holds the information about the forest in detail. So there's an intimate relationship, for example, between the tower and the tree that it stands next to, because the tower holds a description of that tree. That description is what makes up the character of the tower. And the description is transposed into something new that can become part of the wireless network. The next layer of soft urbanism at Harvard Forest is the stones. So the Harvard Forest in the 1700s was almost entirely cleared of trees for agricultural land. The soil was very rocky, and so as the land was tilled, stones were collected and stacked up along the roadsides to become fences and pens for animals. The stones now are a marker of the primary transportation network that runs through Harvard Forest. The stones also create a temporal connection between the people who move through Harvard Forest along the roadways nowadays to the people who moved through this area back 200, 300 years ago. So the stones, as a layer of urbanism at Harvard Forest, are soft. They're soft because they're obviously epigenetic. They literally come from the site and have been transposed through time. But because of the presence of the stones, the roadways have also been transposed through time, so that what is primarily a pedestrian kind of tertiary web-like network that functioned hundreds of years ago is also now the primary way to get through the forest, and it's critical to the functioning of the forest today. The third layer of urbanism at Harvard Forest that I'd like to discuss is composed of trees. And it's probably the trees in the forest that has been able to change the most over time. From the 1700s, when Harvard Forest was almost completely cleared of trees, to the present day condition where its forest cover is extensive, to maybe a future where the trees would come down again because of an insect pest or a dramatic climate event, or maybe even suburban development. What you see in the image here is a bark respiration monitor that records carbon dioxide as it's emitted while the tree goes through its seasonal cycles and also as the tree decays. And so because the trees are studied so extensively, they have become a soft, flexible construction material that builds the forest up, that deconstructs the forest and rebuilds it again. And the construction material is known so well. So the tree as an individual soft building material is understood, but scientists at Harvard Forest also understand how the trees aggregate together and how the territory that they create functions. This image shows the result of a study at Harvard Forest where a portion of forest was taken down intentionally and the trees were cut up or dissected and treated as a kind of data archive so that the scientists were able to reconstruct a complex history of weather events, forest succession, and dominance by a single species of trees. Now I'd like to shift into a discussion about what a future soft suburb in the temperate biome might be or what it might look like. And I think Alan Berger and the team of urbanists at MIT have come up with a really great speculative project that envisions this kind of suburb. So the project visualized on this slide depicts a suburb that is much less focused on the vehicle, and because of that, its ground is much more permeable. It's focused less on the vehicle because people in the suburb might very well be dropped off at their doorstep by an autonomous vehicle that would then go park itself in a garage, thereby eliminating the need for things like driveways. Drones might be delivering goods as opposed to FedEx trucks. It's the signal or the drone that travels the long distances as opposed to the people or the vehicles. In this scenario, the circulation network might be more fine-grained and focused on the pedestrian, and greenfield development might not mean total erasure of the pre-existing forest, which is one of the primary landscapes in the temperate biome. On the contrary, those things, like at Harvard Forest, might evolve over time and become the most basic DNA of the new suburb. Like the towers at Harvard Forest, the architecture of this new kind of soft suburb might be epigenetic or evolved from the basic DNA of the existing site. This slide features an example of that type of architecture. It's the Hi-Fi Pavilion by David Benjamin and the architecture firm The Living. The pavilion was installed at MoMA in New York City, and it was composed of bricks that were grown from mycelium, which are the root-like structures of mushroom. Like the Kushicle by Archigram in the 60s, this type of architecture can be understood as much more temporary. Like the tree at Harvard Forest, a building block that can construct and deconstruct the forest, the mycelium brick at Hi-Fi also is a building block that can construct and deconstruct a building through decomposition. The brick is compostable. And so through Harvard Forest and the example of the Hi-Fi Pavilion, a definition for this new type of soft suburb emerges. It's one that is permeable, living, and compostable. Permeable in the sense that its ground might not have to be composed so that it's oriented to vehicle transportation, living in the sense that one of its primary building blocks grows and decays, and compostable in the sense that it might be understood and even valued as a more temporary land use. It's clear that soft projects and even soft cities are underway and part of the design disciplines already, but it's not necessarily clear that their DNA or their basic material palette is known as deeply or spread as widely as it is in a project like Harvard Forest. This last slide that I'd like to share, I think, is a testament to that fact. What it shows is the Harvard Forest Global Site Network. And Harvard Forest is a part of this network because it has been recording data about the forest long term and shares that data across sites across the globe through its wireless network. But also it is part of the much larger temperate forest biome that wraps the globe and that shares similar characteristics. I think Harvard Forest is a great concrete, already existing case study that we as designers can look to as we move forward into the future and design soft cities that can respond to things like complex climate change, exponential population growth, and still maintain a quality of life. And that's the end of my talk. I look forward to potentially meeting some of you or being in touch in conversations in the future. Thanks.